Welcome back. It's time for video 4 as we continue our studies of Unit 4, looking at multiplying and dividing whole numbers. So let's go ahead and get out to the PowerPoint. Here we go. All right, from current slide. There we go. So the idea of multiplying by base 10, if we are using base 10 blocks, if you're multiplying by a factor of 10, what happens is every stick, okay, will become a flat. Every single gets to become a rod. And if by chance we had flats, then some of you might remember that your three-dimensional cube showed up as well. So again, you could say, well, we're going to multiply by 10. It's an easy way. There's the visual for you. We had 2 sticks times 10 got us 2 flats. 3 singles times 10 got us 3 sticks. So the answer would be 230. We should probably make sure the kids know that if we're multiplying a number by 10 to a power, it just adds that power number of zeros. So if we had 5 times 10 to the second, it's 5 with 2 zeros, 500. If we change that to 5 times 10 to the third, it'd be 5 with 3 zeros, 5,000. So I think that's probably worthwhile for our kids. We should probably emphasize that for them. I'm not going to run these videos for you. However, I will encourage you as you study this unit to go ahead and click out and take a look at how these things are done. I'm sad to inform you that I don't think Kidspiration is now available for purchase, which kind of makes me sad. You can read about it, but everything I've done in terms of research in the last couple of weeks doesn't lend me to a place where I can buy it, which is a little sad. The good news is there are virtual manipulative sites that you can grab, and you can kind of, in effect, do this. So I'll leave that for you to look at. All right, there is another opportunity, and that is one of those places where you can grab those manipulatives. Cool Math for Kids. If you never checked it out, you should. There's a lot of good stuff going on there. So again, something you can check out. The hyperlink should work for you. Go ahead and check it out. I want you to look at lattice multiplication with me. I've had kids in my former teaching existence who transferred into the district where I taught, and they didn't learn how to do normal multiplication algorithm. They learned it by lattice. And it was interesting to work with the kids because they said, I'm much faster this way. And as it turned out, they probably were. So if I were going to do this, I would pass out the lattice handouts. I think it's easier for you as the teacher to prepare them and say, here you go. I want you to do some problems with us. All right. So first of all, we're going to do 23 times 54. Okay, so you see, I've taken the liberty of setting up a 2x2 grid over there because both of our numbers have 2 digits. So we're going to put the 23 across the top as you see it. We'll put the 54 top to bottom as you see it. And now what you're going to see is each of those little square boxes is going to get subdivided. Well, that's pretty spiffy. And you see that lattice look that we saw earlier when we did lattice addition. Well, guess what, dudes? We're not adding this time, we're multiplying. So we're going to fill in each of those grids with 3 times 5. Then we'll do 3 times 4. And we'll do 2 times 5. And we'll do 2 times 4. So again, the order in which you do these doesn't really matter that much. Let's see what Dell did. Dell did 3 times 5. There's the 15. Remember, the 1 goes in the top part, the 5 in the bottom part. We'll go 12 in the same context. 2 5s will be 10. And again, remember on 2 times 4, when it's a single-digit response, it goes to the bottom of those 2 subdivideds. Your author says the 0 is a good idea. This time I think I would agree. Much like before, now we'll add those diagonals. The problem when you do lattice multiplication is the diagonal adds can be a sum bigger than 10. So you have to tell your kids, we'll now have to carry to the next diagonal. So there's your first diagonal, we'll get you 2. All right, notice now, though, when we add 5 and 1 and 8, we're going to get more than 10. We're going to get 14. So we record the 4 and we carry the 1 to the next diagonal operation set. So that's the little pink 1 that just showed up. It now gets added to the 1 and the 0 and the 0 from our next diagonal. That'll get us 2. And last, we don't have much to add in that. We got 1. You get your answer kind of by making an L. That's pretty cool. And so the answer to 23 times 54 should be 1,242. props to us. We just did our first lattice multiplication problem. Nobody got hurt. All right, your author does this stuff with bases that are other than 10. When I was a kid in school, this was what they called the new math. And they used to decide that, well, they'd be better at base 10 if we taught them how to do arithmetic in base 6. I don't think I could disagree more. So I don't think little Susie in grade 3 is going to have to know anything about base 6. If she becomes a programmer and she has to know base 16, then I'll listen to you, or maybe base 2. But in the context of what we're doing to have our kids be better mathematicians, to understand the concepts better, I think we're better served to stick with base 10 and just leave it there. All right, if you are asked to take 4 times 367, you should know that that's going to ask you to take 4 times 300, take 4 times 60, and also take 4 times 70. So in a sense, you're setting up what looks like a distributive property. Okay? That's pretty cool. 4 times each of those players. Get you to that. And you can add, and you get 1468. I kind of like the vertical stack on this. All right, check it. So if you take 4 times 300, I'm going to be able to write, oh, I'm sorry, I'm going to go 4 times 7 first. And I promise in a bit you're going to see 4 times 300. So this time I worked right to left. 4 times 7 for 28. 4 times, now that 6 is not a 6, it's really a 60. So that's 4 times 60 for 240. Now 3 is not a 3, it's 300. 300 times 4 is 1200. Same answer, 1468. I like this. I think I wish we showed it more to kids. I don't know that we do. I think we get right into the algorithm when we get them crunch, crunch, crunch. And sometimes they don't realize that there are other ways to approach the solution to the problem. I kind of wish we could do a better job. All right, so now it's time for mental computation strategies. And you know, you've already heard this from me on Unit 3. Kids will work on this with us in the room. Outside of the room, they're checking out. You know, they're going to go home and run around. They're going to play video games. They're not going to work on this. All right, front end multiplying, probably what you expect. We're going to wind up taking 50 times 4 first. Remember, that's not a 5. In the place value where it sits, it's worth a 50. So there's 50 times 4, that's 200. And that still leaves us 8 times 4, that's 32 more. So again, without doing the tedious carry stuff that a lot of kids get bogged down with, we can show them methods whereby they can do some things in their head and they can get the answer of 232. That's cool. Looks like probably 70 times 6 first. Remember, that 7 is in a 70s spot. So there's your 70 times 6, and then last 2 times 6. So it's 420 plus 12, 432. Certainly, we can do those things. Kids can do that stuff if we showed it to them. If we put enough of these on the board and say, all right, let's do this. You don't need a paper. Let's just get your head going. What can you give me first? What can you give me second? You know, coach them up, walk them through it. All right, this one makes me sad because a lot of kids will do the multiplications in the order that the numbers are written. And I think sometimes if you're willing to look, you can make the arithmetic a little bit easier. So in fact, I think if you were let me take 20 times 5, I would like that. And I might like to take 2 times 5. So I'm going to reset this. All right, I'm going to regroup. I'll let that 7 sit out front. I don't know anybody group him up with. But I do want to take the 2 and the 5. I'm going to group them because that's pretty cool. I want to do a similar group with 20 and 5. So, all right, so what do you got for me, Dale? Well, I think 2 times 5 is a 10. I think 20 times 5 is 100. So I've changed the look of that problem to what I think were easier numbers for us to multiply to get us to an answer of 7,000. Okay? So when you're having your kids work on multiplications, tell them that they may change the order in which the numbers are listed if it facilitates arithmetic for them. All right, I see your author's point here. Sadly, I'm not so sure it's going to have a big effect for a lot of your kids. So think of this as 58 nickels. Now, frankly, I'm not sure that helps a lot of people. But what your author says is, all right, well, 58 nickels could be thought of as 29 dimes, or each dime is 10. So that's 29 times 10. So that's 290. So if you know the notion of having a numeric approach that has a number, a money reference point, 5 was obviously the nickel, and then you had 58 of them, and somehow, you had the insight that that could be the same as 29 dimes before you got something that was easy to do. 52 quarters, I'll bet that is. I'll bet you that's where he goes. 52 quarters, and you say, well, what are you going to do with that? Well, it's 26 half dollars if you've ever seen a half dollar. That's not incorrect. And that would in fact be 13 full dollars. And that's 13 times 100. And that's 1,300. So listen, it's got some validity. I just don't know that it's as useful as maybe I think your author kind of wants us to believe that it is. That, my friends, will shut down video 4 for Unit 4. We'll be back in a bit with our 5th and final video from Unit 4. See you then.